Welcome to one of our Space Science and Technology Portals lectures. The title of this lecture is An Introduction to the Systems of Assembly, Integration, and Testing Center, AITC. The shown picture is a 3D model of Assembly, Integration, and Testing Center, AITC, which belongs to the Egyptian Space Agency. In this lecture, we tackle the following topics: an introduction to assembly and integration activities, an introduction to alignment measurement system, an introduction to mass property measurement system, an introduction to thermal vacuum test system, an introduction to dynamic test system. First, we start with an introduction to assembly and integration activities. Satellite AIT stages are these processes that start with the delivery and acceptance of subsystems. This aims to accomplish all assembly and testing processes and ends with the delivery of a qualified satellite. The final stage is the launch campaign in the launching center as shown. Now we move to some requirements related to the AIT environment, whether it's the assembly or the testing workshop, that should be as follows. Also, the requirements and measures for satellite grounding should be as follows. Electrostatic discharge (ESD) protection is one of the key measures in the assembly process. All products will go through ESD protection within the process of delivery inspection and assembly. Operators must wear ESD protection wristbands when going through the assembly operation on the satellite. Personnel, products, equipment going into the AIT workshop must go through a channel of air shower for cleaning. A ground rod and a human comprehensive resistance tester must be set at the entrance of the operation area. Before entering, all personnel should touch the ground rod and must pass the test of human comprehensive resistance tester. In the process of satellite assembly and testing, there are many sources of pollution: people, equipment, and operation. Operators and their activities are the main pollution sources for the purified room. The body, articles carried inside, area and speed of activity, even the paper and pens being used may cause pollution for the products. All parts and material may cause different levels of pollution. The level has a direct relationship with the feature and protection. There will be contamination caused by delivery, lifting, drilling, or ringing. So, strict and effective protection measures must be taken in order to keep pollution levels under control. In an AIT workshop, if someone is not cleared for access, they must pay extra attention. Some worthy to mention features regarding the assembly operations are as follows. Space in the module is too narrow. Instruments, equipment, cables, tubes are closely installed. Lots of work depends on manual operation. The quality and safety of satellite assembly and test are heavily affected by how skilled the operators are, how responsible the workers are, and how experienced they are. quality of the assembly plays a critical role in satellite in-orbit operation. Generally speaking, the workload of this period takes 35% of the total satellite development workload. Now we move to an introduction to alignment measurement system. The purpose of satellite alignment is to install satellite instruments as in the required design with high precision and to confirm the satellite can function efficiently. The alignment test is implemented many times during the assembly activities, especially during the assembly of sensitive instruments such as the payload, the camera, sensors and actuators, thrust component, the engine, and telecommunication instruments, the antenna. The alignment system consists of two electrical theodolites as a minimum. They are used to measure both horizontal and vertical angles and to record the data resulted from this measurement. A tripod made of aluminum alloy material which ensures good stability is used to install the theodolite. Now we move to an introduction to mass property measurement system. Mass properties of an object including mass, m, center of gravity, COG, horizontal COG for y and z direction, vertical COG for x direction, and moment of inertia, MOI, are all determined by the object's material, shape, and structure. These are important parameters that reflect the object's intrinsic mechanical characteristics. Mass properties affect a spacecraft in several ways. In order to allow the selected launch vehicle to launch the spacecraft precisely into the designated orbit, the mass properties must be provided to the launch vehicle designer and controller. After the launch, a spacecraft needs to be transferred several times before entering its designated deep space exploration orbit. During this period, a great deal of fuel is exhausted. Precisely measured mass properties can increase the accuracy of controlling the spacecraft and thus increase the fuel usage efficiency, which in turn increases the valuable service time of the spacecraft. The motion of the spacecraft must be fully simulated and analyzed in order to verify the accuracy of the spacecraft design before the actual production. Now we move to an introduction to thermal vacuum test system. First, we have to know that space environment is composed of vacuum, cold, black background, and space heat flux, which may cause equipment failure on the satellite. The thermal test is divided into Satellite Thermal Balance Test, TB, Satellite Thermal Vacuum Test, TV. The main purpose of the thermal balance test and the thermal vacuum test is to 1. Verify satellite performance and reliability in vacuum and thermal conditions in orbit. 2. Check the accuracy of satellite thermal design. 3. Ensure that the temperature of the instruments and equipment of the satellite is controlled within the specified range. Now we move to an introduction to dynamic test system. First, it is crucial to know what is dynamic environment. A satellite will endure various kinds of dynamic environments: vibrations, acoustic, shock, acceleration, throughout its whole lifespan. especially in the launching phase. Second, what is the influence of dynamic environment? The dynamic environment may lead to damaging the electronic components, breaking the electronic circuit, loosening the connector and breaking the rack, damaging the main structure and substructure. The main objectives of the dynamic test are to verify design of satellite structure in order to ensure whether the satellite structure can endure various environments, discover potential defects in material and components, which reduces the possibility of early failure and increases the in-orbiting reliability, study the effect of dynamic environment on the new material and new structure, a matter that allows the study of the effectiveness of various vibration isolations.
Thank you for your undivided attention.